Is my screen visible?
Yes, sir.
Okay. So, the last class we were studying about body role and all, body role analysis we have completed. Next, we are going to look at anti-roll bars. Okay. So, we studied what was the reason for. So, we studied the reason for rolling. So rolling occurs when the vehicle takes a curve, and while taking the curve, the centrifugal force acts towards the outside of the curve, and then in effect the body turns. Okay, so that was what is happening inside a rolling action. So that is how the body rolls. So to prevent that, sorry, not to prevent, but to reduce rolling, we are using anti-roll bars. It never prevents it, but it reduces the rolling action that is occurring naturally in a vehicle. So the reason or the rolling occurs due to the transferring of weight from the center of gravity to the outer wheels of the vehicle. So when that occurs, the vehicle rolls through the roll center axis and then goes and crashes. Okay, that is what is a rolling incident. So we are reducing that function. So what does an anti-roll bar does? So it is nothing but, so here you can see a double transverse wishbone suspension. Okay, this is a double transverse wishbone suspension, and you can see a component that is shown here. Okay, a component in this black line, you can see it here. That is the anti-roll bar. Okay, it is called the anti-roll bar. So what it does is that when we are so you can see the figure here itself, the tire is raised up on a hump here. Okay, this condition is similar to that occurring in a vehicle roll. Okay, so I have shown you in the video itself. So when a vehicle is taking a curve, the inner uh, the outer wheel gets compressed. Okay, the outer wheel gets compressed and the inner wheel is lifted up. Okay, so the weight is transferred to the outer wheel. Weight is transferred to the outer wheel, and when this weight is transferred, the way due to that weight, the suspension is compressed and the other suspension lifts up. So in the same manner, we are showing a road hump. Okay, so you know, when we are going from a level road to an off-road condition, when one of the tires goes to the ground and one tire is remaining on the road, when that condition occurs, a same rolling action is done. Okay, if the uh, depth of the ground from the road surface is much greater, the of course the vehicle will roll or it will fall down. Okay, so that is what is shown in this diagram, and to prevent that, we are to prevent such a disaster or to reduce the rolling action, we are providing anti-roll bar. So in an anti-roll bar, what happens is that there will be, due to this action, there will be a twisting moment or a twisting action occurring in this road. There will be a twisting action occurring in this road. And this twisting action results in pulling the inner wheel downwards. Okay, so what is happening here? There is a twisting moment or twisting action occurring at the anti-roll bar, and this twisting action in effect provides a downward force for the inner wheel. So the lifting of inner wheel was the reason of rolling. So if we are pressing or providing a downward force to the inner wheel, then it reduces the chance of rolling. Okay, that is the function of an anti-roll bar. So I'll show you a video of how it works. Okay, when you look in a vehicle, this is how an anti-roll bar is seen. Okay, this is how an anti-roll bar is seen. So if you look in a vehicle, you can see a bar that is provided here, and it will be connected to the wishbone or our suspension or our chassis itself. So it will be connected in such a way that this is our steering column. This is the steering column, and this is our suspension part, or the wheel hub is connected to this suspension, double wishbone suspension here. Okay, and when it is connected, and the anti-roll bar is connected to this wishbone itself, to the lower arm of the wishbone. You can see it is connected to the lower arm of this wishbone. Okay, it will be connected to the suspension or the chassis depending upon what turns. Okay, here the wheel turns or the wishbone is turning, and the rolling action is coming to the tires. Okay, so and for that purpose the anti-roll is connected here, and how it acts is that okay, you can see while taking the rolling, or while taking a roll, you can see how the this is our anti-roll bar. Okay, this is the anti-roll bar. So when the body is rolling, one wheel compresses, another lifts. So sufficiently the anti-roll bar moves accordingly to provide a sufficient twisting moment, or provide the inner wheel to touch the ground. So it will provide that twisting moment into a force to provide the wheel downward itself. So there will be an equal angle of inclination of each of the tires. Okay, there will be an inclination here. You don't have to notice that. So, but this is happening due to the anti-roll bar action. So this is here, the anti-roll bar is in the shape of a trapezoid. Okay, it is in the shape of a trapezoid, and it is acting in such a manner to provide much more downward force. So this is how it is placed, or basically it is a rod that is here. It is a stiff rod, but there will be only twisting motion of the rod, thereby producing this downward motion. So that is what is known as anti-roll bar. Anti-roll bar. Okay. Next, I will summarize all the so we have to then study about these 7 things. Before that, I will just summarize all the suspension components that are present. So please watch the video.
Axle assembly from suspension system is the term given to the system of springs, shock absorbers, and linkages that connects a vehicle to its wheels, and allows relative motion between the two. The suspension system separates the wheel axle assembly from body. A vehicle needs a suspension system to cushion and damp out road shocks, so providing comfort to the passengers and preventing damage to the load and vehicle components. The springs and other components compress and expand as the wheel hits bumps or holes in the road. This allows the wheel to move up and down without moving the vehicle body. Supports the weight of the vehicle. Provides a smooth ride. Allows rapid cornering without extreme body roll. Keeps tires in firm contact with the road surface. Allows front wheels to turn left or right for steering. Isolates the body from road shocks and vibrations. Prevents excessive body squat, tilting down at rear, when accelerating or heavily loaded. Prevents excessive body dive, tilting down at front, when braking. Suspension system includes steering knuckle, control arm, ball joint, suspension springs, sway bar and dampers. Steering knuckle is that part which contains the wheel hub or spindle, and attaches to the suspension and steering components. The wheel hub and bearing assembly is mounted on steering knuckle. Steering knuckle is mounting with tie rod for steering, lower arm, brake caliper, and strut. Control arm is a movable lever that fastens the steering knuckle to the vehicle's body or frame. Vehicles with short long arm front suspensions have 4 control arms, 2 uppers and 2 lowers. While most strut-equipped vehicles have only 2 lower control arms in the front suspension. Ball joint is chassis part that connects the steering knuckle to the control arm. The ball and socket design of the joint allows it to swivel, so the knuckles can pivot as the wheels are steered, and allows it to arc so the knuckles can follow the vertical motions of the suspension, as it reacts to changes in the road surface. Vehicles with short long arm front suspensions have 4 ball joints, 2 uppers and 2 lowers. While most strut-equipped vehicles have only 2 lower joints in the front suspension. The vehicle body is supported by the suspension springs, which are located between the body and wheel axles. There are 4 main types of springs in common use: coil spring, leaf spring, torsion bar, and rubber spring. A coil spring is simply a spiral of resilient steel rod. It is stretched or compressed by the vertical movement of the wheels. Coil springs are most common springs used in front and rear of passenger cars. Coil springs absorb the force of impact by twisting. leaf spring is one of the oldest forms of springing. It is usually
Okay, this is one of the spring suspension that we did not discuss. So it is called a leaf spring. So this is the first type of suspension that was older in design that was used. So instead of a spring and all, we are using various leaves here. So leaves are nothing but laminated plates. Okay, so are plates here, and there are always several plates here. So suspension action happens by the compression of these plates. So you can see some gaps here, right? So when this is compressing, these gaps will close around. Okay, but here um, there will be no such gap, but still it will provide the suspension action. But the action that is provided by this is significantly lower when compared to both the telescopic and coil spring suspension. So this was one of the oldest used, and it is still being used. You can see it in all the lorries and all the lorries that we are going, or the trucks that is going. They still use a leaf spring suspension. You can see the leaf spring itself at the rear wheels and all. There will be a component that is like this. Okay, it will be in the shape of a leaf, and it will be maybe given a inclined or a dome-like structure or a curved structure onto the axle, and it will be present at both of the rear wheels. Okay, you can still observe it in nowadays also, and this is one of the suspension. So you will ask how, if the suspension acts, will the plate break? Okay. So the material is made up of a special material so as not to break under various loads that is occurring inside the suspension. But still the suspension action is still lower, and for that purpose these are becoming obsolete. So it is only present at the rear wheels in trucks and all, but in the front there is usage of uh, coil spring suspension itself. and and these are becoming obsolete nowadays. Okay, because the suspension action is only less due to a small gap, and uh, even during a longer period of use, and uh, under various stresses, these do not break very easily, but it can break um when significant load above the suspension limit is provided to the spring. So that is what a leaf spring is.
used on rear-wheel drive vehicles because of its simplicity. They are normally mounted longitudinally. Leaf springs are constructed of one or more of springing. It is usually used on rear-wheel drive vehicles because of its simplicity. They are normally mounted
So it will be mounted like this. Okay, you can see it in a truck and all. It will be mounted in this way, and this is the differential that is present in the leaf spring. Okay, sorry, this will be the differential, and the leaf spring will be mounted on uh, either sides of the rear wheels or the rear axle. Okay.
longitudinally. Leaf springs are constructed of one or more strips of long, narrow spring steel. These metal strips, called leaves, are assembled with plastic or synthetic rubber insulators between. It is usually used on rear wheel only. Leaf springs are constructed of one or more strips of long, narrow spring steel. These metal strips, called leaves, are assembled with plastic or synthetic rubber insulators between the leaves, allowing freedom of movement during spring operation.
So you can see how there is significant only significant gap here. So once there is that curved motion, even smaller distance are only provided, but still there will be a small gap so as to compress the suspension, or the suspension limit of the vehicle that is occurring at the wheels, and that for that purpose itself only the leaf springs are
And
used.
without creating wear or noise.
You can see how the insulator, the
The
plastic is
longest leaf
insulated.
called the main leaf is rolled at both ends to form eyes. These eyes are used to mount the spring to the frame of the vehicle. Mount the spring to the frame of the vehicle. Main leaf is rolled at both ends to form eyes.
so these are the parts that is shown here. Upper part of the longest leaf is called the main leaf, and the place where the suspension is mounted is known as the eye of the suspension. Then
These eyes are used to mount the spring to the frame of the vehicle.
okay, you can see the eye.
The leaves are held together by a center bolt that passes through a hole in the center of each leaf. Rebound clips are formed at intervals around the leaves. They prevent excessive flexing of the main leaf during rebound, and also keep the leaves in alignment. The front end of a leaf spring is mounted to a hanger, with a bolt and rubber bushings directly attached to the frame. The rear end of the leaf spring is attached to the frame with movable mounting hangers called shackles. The leaf spring is also used to locate the axle on the spring. The axle is then clamped to the spring by U-bolts that wrap around the axle housing and through a spring plate underneath the spring. Torsion bar is a straight spring steel rod with splined or square ends. One end of the bar is attached to the frame, and the other end is connected to the lower control arm. The torsion bar twists around its center as the control arm is deflected.
Okay, this is called a torsion bar. So the torsion bar is provided only for reducing the torsion that is occurring. So what is torsion actually? Torsion is a twisting moment that occurs in a shaft, and this twisting moment can break the shaft. Okay, or we are having the rotating force, that is torque, that is obtaining at each and every component that is rotating, and apart from that we are having a rolling motion even for the vehicle itself. Okay, and due to that rolling motion there will be a chance of torsion occurring on a rigid frames inside or rigid shaft inside the vehicle, and to prevent that there is a torsion bar provided, and this torsion bar is same, it works as the suspension system itself. It absorbs the torsion that is occurring. So in the suspension, the linear forces are compressed, or linear forces are taken by the spring or the coil spring or the telescopic suspension or the leaf spring. While in a torsion bar, the rotational forces, undesirable rotational forces are held inside the torsion bar. So it will twist under that load and then retwist by the rigidness, by its rigidness itself when that force is removed. So that is the function of a torsion bar.
Non-metallic materials like rubber can provide the main springing action, but are more commonly used as stops to limit extreme suspension movement. The stops can also be shaped to provide an auxiliary springing function in light vehicle applications. Bump stops can help cushion the suspension and prevent it from bottoming out. Bump stops are made in a few different designs, so
okay, these are bump stops. So
bump stops can help
here? So here you can see the bump stop that is provided here. So this will be the suspension, right? So when that compressive force occurs, there is a chance of, if this is not present, there is a chance of this metallic component to hit this here, and due to multiple operation there will be sufficient wearing of these two points, and for that purpose we are providing a rubber spring or a bump stop so as to prevent such a wearing out over here, or this wearing out may cause a deformation or a I can fracture these products here. Okay, it's a rigid frame and it's metallic compound. So once the metal and metal contacts itself, there will be sufficient wear, and due to if the force that is acting is greater, there will be sufficient cracks occurring here, and it may finally lead to a fracture. And to prevent that, we are providing a rubber spring which compresses under that load and does not damage both these parts, and that is a function of
the suspension and prevent it from bottoming out.
You can see here.
Bump stops are made in a few different designs, so they mount in different places. Some are placed in line with the piston rods of shocks, others mount between frame and axle, absorbing impact before the axle gets a chance to slam into the frame. Sway bar is also called stabilizer bar or anti-roll bar. Sway bar connects lower control arms on both sides of vehicle. Sway bar operates as a spring when car leans to one side. If one wheel moves up or down in relation to the other wheel, bar twists as it tries to move the other wheel along with it. The energy of road shock causes the spring to oscillate. These oscillations are restricted to reasonable level by damper. There are three types of dampers: shock absorber, coilover, and strut. Shock absorber are conventional telescopic dampers. They are used on all conventional suspension systems to dampen and control the motion of the vehicle's springs. One end is connected to the body or frame, and the other is connected to the axle or control arm. Shock absorbers work alongside springs to reduce the impact of bumps and potholes. There are different kinds of shock absorbers, but they all use a piston sliding in a cylinder filled with oil. A monotube shock has a single piston and rod assembly in a damping case, in which both compression and rebound occur. Also, it has a free piston that completely separates the oil chamber from the gas chamber. The oil flows through a valve in the piston, and the monotube has some volume of gas that accounts for any volume change in the oil. Twin tubes have an inner cylinder which moves up and down, and an outer cylinder which serves as a hydraulic reserve. This design allows for an increase in suspension stroke, which provides better ride quality and handling. A valve at the bottom of the shock allows the oil to flow into the reservoir as the piston moves up and down. A coilover is a suspension device which consists of a shock with a coil spring encircling it. There are two types of coilovers: full coilovers and slip-on coilovers. Full coilovers are matched up with a shock absorber from the factory, while with slip-on coilovers, the dampers and springs are bought separately and then assembled. Coilover is found on many vehicles. It is used in double wishbone suspension systems, and is often a component of McPherson struts. A strut is a structural part of the vehicle's suspension system, and is mounted to the chassis on the top, and they come down through. A strut assembly is made up of the strut, bump stop or boot, spring, spring seat, and mount. The bottom of the strut usually attaches to the steering knuckle, and the top of the strut is connected to the vehicle body through an upper strut mount.
Okay, that is the end of that video. So that's those are the basic components of a suspension. And now we are going to look upon the various rear suspensions that are used. So it will be used in the rear axle, and they are used basically in the rear. So that is why it is known as rear suspensions. And some of the rear suspensions are live rigid axle suspension, non-drive rear suspension, swing arm rear wheel drive independent suspension, low pivot split axle coil spring wheel drive independent suspension, trailing and semi-trailing arm rear wheel drive independent suspension, transverse doubling arm rear wheel drive independent suspension, then DD on axle rear wheel suspension. So these are some of the rear suspensions that we are going to discuss. So one of the first and foremost suspension that is used is known as live rigid axle suspension. So what is known as a live axle? Live axle is nothing but the axle in which the power is distributed. So basically, rear wheel drives are the most commonly used. Hence, the use of live axle is basically present at the rear. And when it is present at the rear, we are using live rigid axle suspension. Live rigid axle suspension. So what happens is that we are providing suspension components to the rear axle. So there will be a differential present, and on that differential, from that differential, an axle or 2 points to each of the wheels are given, and from there the power is transmitted. Hence, the axle is known as live axle, and we are mounting components onto that. And one of the components or the suspension components that we saw that is being used was the leaf spring. Okay, the leaf spring was used, and the leaf spring was one of the suspension, earlier suspension used, and it is still used in heavy lorries and trucks, etc. And that is one of the suspension that is present. Then comes the telescopic and the coil spring suspension that we have already seen, and these suspensions are also provided on the axle. But the axle is a rigid axle. Okay, it may be when subjected to a vertical force rather than a rotational force. Since the axle is rotating, we are obtaining the power here, but um, when in the case of a linear load, we are providing suspension components, and this suspension components are then used for the distributing or for absorbing the vertical load that is obtained at the wheels. Next, you can observe that some characteristics are present in live rigid axle suspension. Here the wheel camber is zero if the vehicle is stationary or moving in the road. So wheel camber, you know what is wheel camber. So when we are looking from the front of the vehicle, if the tilting or the inclination of the wheels is known as camber. Okay, inclination of the wheels from the vertical of the ground is known as camber, and we are discussing the camber basically on the rear wheels itself. Okay, we are not discussing about the front wheel, we are all discussing about the rear wheels. So the wheel camber is basically zero if the vehicle is stationary or moving in the road. Then next, if the one wheel travels over a dip in the road, then the axle will tilt. So there is will be a tilting axle, tilting motion of the axle. So why does this tilting occurs is that because it is a half axle in the means of a differential. From a differential, the power is transmitted, and the differential is a half shaft. So there is a gear called a pinion gear, and from that gear, two shafts. So there will be two pinion gears, and one from one pinion gear, a shaft is mounted to one of the rear wheel, and from the other pinion wheel, it is another shaft is mounted to another wheel. Okay, and due to that, and when one wheel travels over the dip or in the road, then the axle will tilt due to this half axle that is provided inside. But when we are looking it over, we will see a single axle because the differential unit is covered inside a differential box. Okay, for that purpose, we don't see that if it's a half axle and all, but it is generally a half axle, and due to that, the axle will tilt when one wheel travels off a dip, and this tilt is then absorbed by the suspension geometry. Okay, so that is why we are providing the suspension geometry. Then wheel track remains constant under all conditions. So what was the wheel track? Wheel track was nothing but the distance of the center of the tire. Okay, one tire to the other tire. If you are taking the rear direction from the outer tire to the inner tire. Okay, so that is the distance of so that distance is known as wheel track. So wheel track always remains constant in live rigid axle suspension. It doesn't move. Okay, so we are controlling only the wheel track that is present in the front wheel itself. So the turning action is done in the front wheel, while the rear wheels always they do not rotate. Okay, sorry, they do not incline, or they do not turn, but the front wheels only turns for turning of the vehicle. Okay, then in live axle the unsprung weight is very high. So what was unsprung weight? So the roll weight that we had studied earlier in body roll case, that is the weight that is called the unsprung weight. So since the unsprung weight is very high, if there is a shift in weight, body roll occurs more easily in live rigid axle, in live rigid axle. Then the live rigid axle is attached to the body by either leaf or coil springs. So these are the suspensions used in live rigid axle suspension. Leaf or coil springs are employed at the rear of a live rigid axle that is present at the rear. Okay, on the rear live rigid axle, we are providing leaf or coil springs. So I'll wind up the class today. Rest we will discuss in the next class. Next, I will take the attendance.